Hello everyone. Today we are going to discuss the problem of the weekly contest of Leetcode. Count visited nodes in a directed graph. So let's understand the problem statement first. So there is a directed graph consists of n nodes numbered from 0 to n minus 1 and n directed edges. And you are given this array as is where as I indicates that there is a s from node I to as is I. So consider the following process on the graph. You start from the node X and keep visiting other nodes through edges until you reach a node that you have already visited. Before before doing this same process, so we have to return the answer array is the number of different nodes that you will visit if you are perform the following. You have performed the process starting from a node I. So let's understand the problem statement in deep. So yeah. So if so having this graph, so having a graph in which the I know the nodes. This is a directed graph. So what we have to find? We have to find if we start like in this example, if we start from the zeroth index, if we start from this index, right? If we start from this index, so how many edges we can cover? So if I start with this, so I can move to one, then I can move to two, and from two I can move to one. So I can in total I can move I can reach three edges from this, right? Three nodes from this. Similarly, if I redraw this, so I can move three edges from this. And similarly, if I start from one, so I can go to this, I can go to two, and I can go to zero, and one is already visited, so I can visit three nodes from this node only, right? And if I talk about from this two, so in the similar way, I can move to zero, I can move to one, and again two. So I can move three edges from this. And if I talk about from three, I can move to zero, and from zero I can move to one. From one I can move to two, and I can move to zero. Yes, right. So I can so from three I can visit four edges, all the four nodes, right? So it's given that there is only one edge from every node. So let's suppose if we uh, if we find the total sort for this, like uh, we uh, we get all the nodes which are which having a circle, right? If we get those edges, right, which are in a circle, if we get those edges, if we get those edges which are in a circle, so like in this example only, if I get 0, 1 and 2 are in a circle. So I know if they are in a circle, so all of them having the same value. So I compute for 0 only and give the same value to all of the nodes. And from any other node which is not in a circle, if I reach to any node which are in a circle, so what can we do? Like this having only this is already in three, so it's having the count of visited nodes is one. So when it's go to zero, it's already found that it having it can from this index I can reach to four other indexes. So I just take that value and increase my count as four. So the basic idea is like we have to find in a sequential order. So first we mark all the edges which are which having in degree zero. So why we are doing this? Why we are finding all the vertices which having in degree zero. So if a node having in degree zero, like if no edge is coming to a node, right? And so it's having in degree zero. So if it having in degree zero, then we can definitely say this edge should not be in the circle, because if in a cycle, if two nodes like one node is here, one node is here, one node is like one node. So if I draw, so this is the node, These are three nodes. So if the as is like this and the as is like this and this as is like this. So in this, if as if as is in circle, then it having definitely in degree one or more. So if a node having in degree zero, then we can definitely say that this as is not going to be in a cycle. So first I compute the those edges. I compute for those edges like which having in degree zero. I just do a topo sort for that. So if I do the topo sort for this, I found that 3 having in degree zero initially, and then no other node having in degree zero now. So only mark node is 3. So I mark this node as visited. Then what we do, we know the all other nodes are in a cycle. So what I do, I just call like I start a DFS from this node only and just call a DFS from that node. And when I found that it is in a cycle, means we know definitely it is going to be in a cycle. So when I found that when I like I visit, I start doing the DFS from the node zero and I move to one, then from one I move to two, and from two again zero. So here I got a cycle. So when I got the cycle, I just what I do, I just store my answer of that node means how many nodes I can visit from a node in this cycle is the size of the cycle, is this number of nodes in this cycle. So if from zero I can move to one, from one I can move to two, from two I can move to zero. So all the nodes are in cycle. So we can definitely say that the number of nodes visiting we can visit from any node in the cycle is the size of the cycle. So the number of nodes in the cycle is that. So we can mark all the values inside the answer vector as 3. So we can definitely say that from these nodes we can move to 3L. So now we are done with the all the cycles. Like we just do in the similar way, which I mark all the nodes which are not in a cycle with 1 initially, and then I perform a DFS for all other nodes which are in a cycle or which are in a cycle definitely. So we just do this. So we are done with the nodes which are in a cycle, right? So now we are only left with those nodes which are not in a cycle. So like in this case, 3 is not in a cycle. So from 3, I call a DFS from those nodes which are not in a cycle. So from 3, I call the DFS and I found that I reached to 0. So here I reached to 0, right? So I know this is already having some storing some answers. So I just give that value to the 3. So it's increase the count of 3 by the value of itself. So it's now for the node 3, it's having 4 nodes which 3 can visit. So in this way, I just solve for all and store the answer. So it is quite good question. So let's see the code for a better understanding. So first of all, I store the as a graph. I store initialize the adjacency list and a visited array, and I store a topo. I am doing a topological sort here. So what I do, I just store mark all the nodes as visited, which having in degree 0. So in this function topo s, what I am doing, I just mark all the nodes which having in degree 0, right? So I just mark all the nodes as visited. So here I'm doing this. So now I having all nodes in unvisited which are going to be in a cycle. So then what we do, we just check whether a given node is already visited. So if it is not, I know it is going to be in a cycle. So I just then this I call a DFS from that node, and whenever I found in the set I am storing the values. So I show you the DFS function. So in the DFS function, what we are doing is we are just pushing the values in the stack and just mark those nodes as you say, and calling the DFS again and again till we are till then we count that having the end like it's complete the whole cycle. So just I push all the nodes in the cycle, and then what I do, I just uh, update the nodes with the size of that. So I store the size of the stack in the count and just update the answers of that, the number of nodes from that, number of nodes we can visit from that specific node. So I just update the all with count because we know all are in a cycle. So definitely the whole size of cycle they can visit only, right? So then I just pop out one by one. And now I am done with the nodes which are in a cycle. I have to now check for the nodes which are not in a cycle. So again, I create a visited one which is storing the number of nodes which are in a cycle. So when we found that this the number of, like we found a given node is not in a cycle, then I just call a DFS from that, and again I store the sequence node of the nodes from the nodes the given specific node is going to visit. I just store in this node sequence. So I will show you the DFS1 function. So in this, store the I just increase the count as well, and whenever I found any visited node, like I found a cycle, or if I found a cycle, then what I do, I just uh, increment my count, means the number of nodes I can visit with the value of that node, because I can I can traverse those many edges from that edge, right? So I just return from that, return here, and then I am done with the node sequence. I choose the nodes in the sequential order because here only one edge can be from a given node. So I store the number of nodes in the node sequence, and then I run a loop in the node sequence, and I know having a count, like I store the number of nodes I can visit from a given node is stored in the count, and I having the sequence of the nodes, like in the way we are going to visit. So I know when from the first node I can visit all the number of nodes which is stored in the count, and from the second node I know I can't visit back to the previous node, so I subtract J here, means one in a sequential order. So right, then I store these as a, also in the I store the answer for these as is, and finally I return the answer. So I hope you enjoy this video, and for more such videos, like and subscribe to our channel. Thank you.